has provided us with a limited number of free coupons into his Udemy course where you can get one-on-one help, you can get help with your homework questions or any other problems you may have. And all you need to do is enter in the coupon code YouTube free, all one word. And I will include a link in the description of this video with this coupon. There will also be a discounted link in the description for you to enroll. And I'm also going to put this course into the complete MATLAB course bundle on my website. There are already 4 courses. This will make it a total of 5 courses included when you purchase the bundle. And this is a fantastic value, especially if you're interested in app designing, MATLAB programming, data analysis with Excel, and much more. So without further ado, let's get started.
Welcome to the course, Advanced MATLAB Data Types and Data Structures. So let's see what we have in this course. In the first segment or section of this course, we will be introducing you to the instructor and the course introduction. In the second section, we will be looking at the basic data type, that is the cell data type. So we will be looking and covering topics such as accessing data elements in a cell, adding and deleting elements, visualizing cells, and then concatenating cells, and many other relevant topics. In section 3, we will be looking at another important data type, which is the table data type. We will be looking at how to create tables, add metadata about the tables, row selection and reordering, different properties of tables. And we will be also looking at how to store and retrieve the table from the memory, and then operations such as adding and deleting columns from a table. In section 4, we will be looking at the timetables data type, and here again we will be covering how to create timetables, and then looking at some of the important properties of the timetables. Then we will be looking at how to sort and perform data selection on the timetable. We will be also covering indexing and retrieving data based on the row times and many other relevant operations. In section 5, we will be looking at the structures. So the topics again that we will be covering here is how to create structures and how to retrieve data from a particular field of a structure. Then we will be also looking at how to concatenate structures, storing data from a structure, a field in a variable, and many other relevant operations. Then in section 6, we will be looking at another important data type, which is the map container. So we will be covering more or less different operations on the map containers and how to create them. And then finally, in section 7, we will be looking at how we can convert between these different data types. So we will be covering first how to convert from a given data type to other data types, and then in the later part, we will be covering at how we can convert from different data types to a target data type. So that was the brief introduction to the course. Hope you will enjoy it.
Hello everyone, my name is Noman Azam. I received my PhD from University of Regina. It is in Canada, and currently I am serving as an assistant professor in the Department of Computer Science in the National University of Computer and Emerging Sciences, and it is in Pakistan. So before starting the course, I believe it will be useful to explain briefly my experience with the MATLAB. So I started to use MATLAB in around 2007. The prime reason why I chose MATLAB was that it was very good for research. That is, if you want to code ideas into working products, it is very useful for that. And also it is very fast to code ideas. So during my experience, I touched almost all the aspects of MATLAB by covering its different toolboxes and its different built-in functions. In the MS thesis, I worked on the problem of email classification, and all the code I wrote was in MATLAB. Similarly, in the PhD thesis, I worked on the problems such as text classification, rough sets, game theory, image processing, recommender systems, and others. And all the code I wrote was in MATLAB. So I had over a decade of experience in MATLAB, so that pretty much summarizes my experience and different aspects of that.
Finally, it will be also very useful to look at some of my courses on the Udemy platform in the MATLAB niche. So I have in total 4 courses prior to developing this course in the MATLAB niche. These are some of the statistics for these courses. So in this course, which is regarding to app designing, I have a total rating of 4.5, and there are 813 students. So for this one, it is also related to app designing, and we had 4.8 overall rating with a 559 students. This is a MATLAB course which covers multiple aspects of MATLAB programming and app designing. It has an overall rating of 4.1 with 1,500 students, and this is data analysis course for MATLAB for those users who are coming from the Excel background. So I have a total of 4.4 ratings over here, and alongside with 1,300 students. So I hope that you will also enjoy my new course on the MATLAB. And in this course, the main motivation for developing this course was that I have been working in the MATLAB niche on the Udemy for more than 6 months, and I observed that the essential data structures, which are very important for learning and becoming an expert in MATLAB, they are not being covered in the courses that are present on the Udemy platform. Finally, you will find all of my courses on the first page of the Udemy in the MATLAB niche, and out of the first top 5 courses, you will find 3 of my courses that are being listed over there. So hope you will enjoy this course as well. See you in the course. Hello students, welcome again to the new section and a new segment of the course. In these lectures, we are going to look at the cell data structure. So the cell data structure is an essential component of your MATLAB learning, and the essential difference between the cell data structure and the other usually used data structures such as the matrices, arrays, is that the cell can contain different types of data, right? So earlier we have seen that the matrices and the arrays or the other variables, they can contain only one type of data. So the cell can contain different types of data. More formally, a cell is a data type with indexed data containers called cells. So each data container is called a cell, and each cell can contain different type of data. The requirement on the cell is that it is rectangular in shape. By that we mean that if we have 3 rows in a cell, so all the 3 rows should contain the same number of columns, right? And if it has 5 columns, then each and every column should contain the same number of rows, right? So we can define a cell, for instance, of 4 cross 3 or 3 cross 7, right? So whatever size you want, but it should be rectangular. So that's the few things that you should note about the cell. So now let's straight go to how we can define a cell. So there are essentially 2 ways to do that. One is if you want to directly define the values that are going to be part of the cell. So in that case, you need to mention it using these curly braces. So by these curly braces, you are going to define the individual values that are going to be part of that cell, right? So if we create it like this, so it will say a 0 cross 0 empty cell array. The other way is to use this reserved word cell and then use these brackets instead of those curly braces, right? And then mention the size of that particular cell. So if we mention 4 cross 6, so it will contain 24 cells, right? So similarly, we can have 3-dimensional cells, and you can say it like this, or any other dimension that you want. So the essential difference between these 2 definition types is that with this, it is expecting the individual items which are going to be part of the cell, and with this, it only expects the dimensions of the cell, right? So these 2 are the ways. So let's do some more examples with the first method. So here we can mention the individual values, and the individual values needs to be separated by this comma, right? So it means now a 1x3 cell. So similarly, we noted earlier that the cell can contain different type of values. So now I am mentioning the second row. The first cell now contains a textual data, and here I can mention the built-in function that is the range, and I am initializing an array, a matrix, a three-dimensional matrix over there, and then finally I can mention my cell. Right? So now it contains different types of data. So when we press enter, you may notice that it has created a 2x3 cell array. The first cell contains only a single element. The second cell also contains a single element, and the third cell also contains a single element. However, this first cell in the second row contains a textual data, and now it contains a 5x2x3 matrix, right? And this contains also a string data. So there is also a very important function in order to look deeper and visualize the contents of the cell, and that is called cell plot. So it is very useful in order to look at what are the different cell elements. So in this case, it says that the first cell element is just a single data item. Again, a single data item and a single data item, right? However, the second row and the first element in that, it is a textual data, and it contains 4 pieces of text, right? So text, that is the text that is going into these individual boxes. And then it is creating a 5x2, right? So it is 5 rows, 2 columns, and then there are 3 separate versions of that. So it means 5x2x3, right? So 5x2 are the array, our matrices, and they have 3 instances of that. And finally, my cell, it is also containing over there. So it's a useful way in order to look at what are the individual contents of your cell. That is the cell plot. It will give you some intuition behind like what is the cell containing. Okay, so one more important function is the cell function, the cell display. So it will display all the contents of the cell, that is cell by cell, right? So first of all, it will display all the items that are contained in the 1,1 cell, which is this one, and then the 2,1 cell, which is the textual information over there. Then it will display the contents of 1, 2, and then 2, 2, and then 2, 3, and finally the 2, 3 cell, right? So it is going to display it, but the display order is like this, right? So it is column-wise display. So that's it for this lecture. In the next few lectures, we will be looking at some more operations on the cell. So stay tuned. Hello students, in this segment we will be looking at some more operations on the cell. So remember, we have created a cell in the previous lectures, which was this one, right? So in this segment we will be looking at how we can actually access the individual elements within this cell using the indexing. So one way of doing it is to use the curly braces, right? So if we use the curly braces, so the curly braces and mention a particular index within this cell array, so it will return the contents of that particular cell array. Right? So, but here we have an exception. That is, if it is a simple item, it will return you the value there, right? Whatever we have at that particular location. However, instead, if it is not a simple value, but some other kind of data structure, for instance, if we consider this one, this is not a simple data, it is 5x2x3 matrix, right? So if you mention that, that is the second 2,2 item here. So if you press enter, it will return you all the values, right? So how we can actually get the individual value within this particular cell? So it is not going to give you individual values, and we are interested in the individual values that are present at that particular cell. So for that purposes, you need to use the smooth brackets after these, right? And if you are interested in a particular item, then you can mention the index of that, right? So for instance, if we say 1 comma 1 comma 1, so it is going to give us the first value that is present in this particular cell, which is 0.6022. If we say 1 comma 2, right? So 1 comma 2 will be this value, right? Comma 1. So let's do that. 1 comma 2 comma 1. So it is going to give us the second value. And if we are interested in this value, so we need to say second row corresponding to the first column, and within this first data item we are looking at, so we need to say 2 comma 1 comma 1. So in that case, 2 comma 1 comma 1, and it is going to give us 0.3868, which is the exact value over here. So the thing to note is that with the curly braces, you can actually get the items, the values that are there at a particular cell. But if the cell is composed of some complex data structure, so you can use these smooth brackets in order to get the individual items extracted out of that particular cell, right? So let's see again and do it one more example. So for instance, if I want to retrieve this, which is the textual information, so how we can do that? I need to mention its corresponding index, which in this case is 2 comma 1. So it will give me the value text. However, if I am interested in these individual items, that is T, E, X, and T, so I can still do that. And I can mention the first value, that is T, the second value, that is E, and similarly the third value, and so on, right? So that is for if we are interested in the individual items within that particular cell. So you need to use these brackets, right? So for with the curly braces, you can get the individual items of the cell. However, if you mention and use the convention that we frequently use with the matrices and arrays, so if you use those smooth brackets and mention a particular location, right? So 1 comma 1, so in this case it will not give you the value that is present on that particular cell, rather it will give you another set, right? So it will give you a set which contains the information about that particular cell, right? So if I mentioned 2 comma 2, so it will give me the complete set, and its type is going to be a cell, right? Not the contents. If I'm interested in the contents, then I need to mention it with the help of those curly braces. So that's the essential difference between the two. That is, with the smooth brackets, we refer to the sets of cells, and with the curly braces, we are interested in the values that are present there at a particular cell. So let's see one more interesting example. If we contain somehow cells that are contained within another cell. So we know that we can define cell with these curly braces. So now this contains more cells, right? So this is a particular cell array, and this is present within this bigger cell array, right? So if we look at it again and see the C, so then the C contains, this is a simple cell, this is another simple cell, and so on. However, it says that it is another cell which is contained within this C. And if we look at cell plot, so we may get more intuition about that. So now it contains another cell, right? So it has the same it has those boxes which contains other boxes as well, so it means it is another cell. So if we have that situation, and if you want to retrieve the contents at that particular cell, So it will give you cell itself, right? Not the contents, right? Because it contains a cell. So what is the way around to get to those individual items? So you need actually to use a double indexing with those curly braces, and then you can mention the individual values over there. Right? So it will give you the contents now. Why? Because for the first one, we get the contents that are present at that cell position, which itself is a cell. And then we get another brackets in order to get the individual contents out of that cell. So that's how it works. Alternatively, you can also mention it like that, 1, 1, because it contains only one row, 1, 2, and 1, 3. Or you can directly mention it. We know that for the column, for the vectors, you can either mention it directly or you can mention it explicitly by saying 1, 1, or 1, 2, or 1, 3, or directly simply by 1, 2, 3. So that was a little bit a tricky part, and you can always think of if it contains further cells and so on. So if there is a 3 level of cells, so then you need to index it using three curly braces, right? So that was it for this section, and in this section we learned how we can actually retrieve the values from a particular cell. So hope you're enjoying the course. See you in next segment. Hello students, welcome again to the new segment. In this segment we will be looking at how we can actually concatenate or combine different cells together. Different cell arrays together. So there are essentially two ways. One is to combine them horizontally, and the other one is to combine them vertically, right? By vertically we mean row wise, and by horizontally we mean column wise. So let's define a few cell arrays. So this is our cell array 1, which contains 1, 2, 3 values, and this is our cell array 2, which contains some strings or characters. And then we have cell array 3, which contains some more values. So now if we want to concatenate them together, so one way of doing it is to just supply the names of those and include it in square brackets. So when we do that, it's going to be concatenated in a single row, right? And remember, it will be a single row, and all the contents are going to appear here as they were appearing over there. So instead, if you enclose it in the curly braces, so now the meaning will change. The meaning is that we are defining a cell whose first element is going to be this one, the second element is this, and the third element is this. So it is not going to be a 1 cross 9 cell array. It is now going to be a cell array of 1 cross 3, right? And each and every element is itself a cell, so it is 1 cross 3. Each of them is 1 cross 3, right? So it's a little bit different. So when we include it in the curly braces, it means that we are specifying individual elements of the cell, of the corresponding cell. And these individual elements can be single items, or they can be itself a cells. Or when we enclose it in square brackets, then we means we are supplying its individual values, and please consider them while we are defining that particular cell. Similarly, if we want to concatenate the cells row wise, so then we need to insert a semicolon between the different values, and then it will append them row wise. Similarly, for column wise, we can delete that, and then it will append them in a single row, and it will be added as columns, right? So these are the 3 values corresponding to C2, and they have been appended as columns, and these are the 3 values corresponding to C3. Similarly, if we add curly braces over here, so then it will means it will have a different meaning, right? It will return a column vector of cells whose individual items are 1 cross 3 cells themselves, right? So that's the essential difference between the square brackets and the curly braces. With the curly braces, we are specifying individual elements that are going to be part of the cell, and with the square brackets, we are actually mentioning the values, right? So these two can be handy. So finally, we'll look at how we can use actually the different elements or the different cell values that are present within a cell. So we can extract them, basically the different elements, and then you pass it to some built-in functions. So for instance, let's have a look. We define, first of all, we clear C. Okay, so then we define C as, let's say, we define some values over here. So we say plot data, and then the second cell will contain the data, right? So we want to have some data, random data, and we call it 20,2, right? So when we press enter and look at what C contains, so C contains only 2 elements. While if we look at cell plot, so here we may notice that the C contains 2 cells. In the first cell we have this data, that is plot data. It is a string array. And then we have, in the second cell, we have 20 rows and 2 columns. So a 20 by 2 matrix over there, right? So these are the 2 elements. So let's suppose now we want to plot these values, right? So how we can do that? So we can use the plot function. And with the plot function, we can actually pass this second element, right? This second element of C. So how we can do that? We can actually mention its contents. So it is a 1,2. Its location is 1,2, and we can pass it to this plot function. And then when we press enter, we get the corresponding data. So that's how we can pass the data of a particular cell into a particular function. If for some reason we only want to plot only the first 20 values corresponding to the first column and not the second column, so we can always do that. We can specify that I need all the rows corresponding to only the first column and then plot it. So we expect one plot over here. Remember that we have covered it, that whenever we mention after the curly braces, if we mention the smooth braces, so we can actually access the individual items that are present at that particular cell location. So that's how we can do that. That is parsing particular cell values to a particular function. Hope you're enjoying the course. See you in the next segment. Hello students, welcome again to the new section and new segment of the course. So in this series of lectures, we will be looking at the table data structure, which is available in the MATLAB. So the table can actually hold different types of data. That is, it can hold numeric data as well as character data or string data, or any other forms of data such as categorical or logical variables within the same data structure. So in contrast to arrays, that is the main difference of the tables. So let's see and go straight how we can define tables. So the first thing that you need to remember is that the tables needs to be created from the already existing variables, or you can import some data into the tables. So let's create few variables. Suppose the first variable is the age variable, and I define it as containing some values. Well, let's say 5 values. And now we can have another variable that is height, and it can also contain some value for 5, 9, and 10, let's say. So it also contains 5 values now. Similarly, we can have the weight variable, and it will hold some values. For instance, 85, 90, 78, 56, and 42. So now if you want to have a single data structure which will hold all the 3 values together, so for that you need to create a table. So you create the table by a keyword known as table. So that's the MATLAB reserved word. That is, you cannot use it in your coding in order to create a variable name. So that's reserved. So we need to say t equals to table, and then we need to mention the variables the variable names that we want to include in this table. So in this case, we have an age variable, and then the next variable is the height, and the final one is the weight. So when you press enter, it will create a table. So now if you look at what's the type of your different variables that exist, so it says T is a 5x3, right? So it is a table data structure which contains three values: age, height, and weight. Okay, so there are different operations that you can do on the particular table. For instance, you can add the row names over here, and how we do that, we can either define a new variable, for instance, say last names, and it will hold the values for the names, for instance, my name, and let's say some other names. And one more, because we need to have 5 rows over there. Right, so now we have 5 values for this last name. So now let's make them as the row names over here in this table. So basically we need to say T equals to this, and then we need to give it an option, which is the last names. And then we need to mention what we want to have as a last names. So that is stored within this variable. Okay, so actually we need to say we need to say row names instead of last name. So we need to say row names. And then when we display the table, we may note that we have our row names appearing here in this table as well. So, right? So, but it's not a good idea actually to every time redefine our table. So for instance, if we add something else, so this table will be redefined. Another way of doing the same is to say T dot properties dot row names. So now we can access individual elements or individual properties of this table using the dot notation. And we can set it to last name variable, which contains our last name. So it has essentially the same effect. So similarly, if you want to change the variable names, so you need to say here variable names, right? And then you can mention some variable names over here. If you don't want the default variable names, remember that the default variable names are the names of the variable that you defined and included within this table. So let's have a look that we have the variable age, so it will now appearing as a default column name for that variable. So if you want to change that default, similarly the height was the name of the variable which contains these 5 values, and weight. So if you want to change these defaults to some other value, you can do that. Suppose I want to say ages in foot, and I want, instead of height, I want to mention that heights also ages in years and height in foot, and then I want to mention that weight is in kgs. So when I press enter, you may notice that the variable names have been updated. But one thing more is that now the row names are not appearing over here, and that's because we have redefined this whole table, right? So now this is according to the new definition. So one way of overcoming this problem is to mention the row names as well and say the row names are contained in our last names variable. One way of doing it is this, but again the correct way of doing it is to, once define a table, don't change its definition, rather change it with respect to the properties, right? So change the properties, and in this case we want to change the property row names, and we want to set it to the last name variable. So when we press enter, we now have both. We have the names as well as this. So once defined a table, don't redefine it, rather change it within by using these properties, right? And with the dot notation, you can actually you can actually modify its different properties. One thing more is the default definition of a table is like this, that you have this table reserved word and you assign it to some variable, for example t1, and then mention variable names, variable 1, variable 2, right? And these are your MATLAB variables and so on. And then once you mention all the variables, the next thing is that you need to say a name and then the value. So these are actually the names, for instance, the options such as the row name, column name, and there are so many other different properties that you can change. So these are the names of the properties of the table. And these are the corresponding values. So you can mention as many property names as you want with the corresponding value and so on. So that's the general syntax of defining a table, right? So essentially in this lecture we have covered how to define the table data structure and how to set its rows and columns. So in the next few lectures we will be looking at some more useful operations on the table. So stay tuned. See you in the next segment. Hello students, welcome again to the new segment. In the last segment we have looked at some basic operations on the table. So we built essentially on top of those. Hello students, welcome again to the new segment on the tables. So in the last lecture we mentioned that the table needs to be created from the already existing variables. If for some reason you do not want that and you want to define the tables yourself, so then you need to mention all the values that are going to be part of the table yourself. So for instance, I want to have 3 values for the first variable, and then I want to have another set of 3 values for the second variable, and then I want another set of 3 values for the third variable. So then when we press enter, there's going to be something wrong. So let's fix that. We need to give it a row, a column vectors. So now we have created the tables. Since we have not mentioned the names of the variables, so that's why the default names are var1, var2, and var3. We can always change that by saying t1.properties, and we are trying to access the properties variable names. So you can say, give it the names of the variables. So the first variable I want to say variable 1. For the second one I want to say variable 2, and similarly for the third one I want to say variable 3. So now we have updated our variable names here. Some other interesting properties that you can modify for the tables are, number 1 is the variable units that you can mention. So remember, we have created this table in the last segment. So we can actually add some units to the description, units for these particular variables over here. So for example, in ages, I may mention that t.properties, and I want in this case the variable units, and I want to mention them for all the variables. So for the first one, I want the ages to be in years, so I say years. And then for the second one, I want to mention it in foots, so I may say something like this. And then for the third one, I may say kgs. So when I press enter, it is going to be, oh sorry, we need to say units. So now it's going to be applied. Now you may wonder where it has been applied. So in order to look at some statistics of this table, we may use this summary option. So summary keyword, and then pass it the table as a parameter to it. And when we press enter, it's basically giving us some statistics about our tables, right? So the units that we have mentioned, it is also appearing here. So what essentially it means is that it is a kind of a metadata What do we mean by metadata? Is the data about the data. So it is our original data, and there is some data behind this, which is this, right? The units for the first variable, and it is also giving us the min, median, and max of this particular variable. So it gives us some basic statistics about the different variables that are appearing as part of our table. Similarly, we can add descriptions. So we can add description for the different variables, and we can say variable description. If we don't mention something over here, it means that the MATLAB is expecting description of all the variables. But if we mention some value over here, for instance, our first variable is ages_years. So if we only mention some description, it will only be applicable for that particular variable. Right? So we can say this variable contains ages in years. So that's our description. Probably there's something wrong in the spelling of description. We need to say descriptions over here, right? So that will aid the description for the variable ages_years. But again, in order to look at it, it is stored as a metadata. So we now have the description for our ages variable, units, and then description. If we want to add description for all the variables at the same time, so we just need to take rid of this additional argument, and we need to enclose it in an array, in a structure. So we can mention for the second variable is description. For the second variable, we want this represents height. And similarly for the third variable, we can also add some description. This is the weight variable. And then we can press enter. So now that descriptions has been stored as a metadata, and in order to access that, we can always see its summary. So now we have the corresponding descriptions as well. So it's quite useful. In the later lectures, we will be looking at how to store these tables, and then you will be looking at that this description is quite useful when we save it to a permanent file. Right? So this description will always be saved with the tables as well. The other important thing is that if you want to access individual elements of a table, for example, I want to access only the first variable, that is the year. So we can always use the dot notation, and we can say t.ages_year, and it will return the first variable for us. Similarly, if we want to access the second and third, we can mention their names. So make sure we don't make any mistake. Okay, so probably the name is not base, so I misspelled it. Yes, so we have now the corresponding values over here. Similarly, we can do some operation on that. For example, we can say this is equals to t.weighs_kgs multiplied by 2. So you can think of all the operations that you may use within the MATLAB environment, and you can do that. So now our weights have been updated, right? So that was only one way of accessing different variables. Of course, there are other ways for accessing the different columns and different rows within the table. That we will cover that in the later segments. That's it for now. See you in the next segment. Hello students, welcome again to the new segment. In this segment, we will be looking at how you can select portions of the table and do some manipulation on top of that. For instance, you may want to select some particular rows or some particular columns from the table. So remember this table, we have created it in the last segment. So let's now look at how we can actually select some of the rows or some of the columns from this table. So for that purpose, we can actually use the colon operator, which is this one. And with this colon operator, we need to mention the initial point and the end point. So for instance, if we say 2 to 10, so it will mean the numbers from 2 to 10. So if we say t and then mention 2 to 4, so the first argument here, it will represent the rows that we are trying to select. And if we say it without mentioning the initial and the final, and the second argument is for the columns, so if we don't mention the initial value and the final value, so in this case it will select all the columns. So this essentially means that select from row number 2 to row number 4 and all the columns. Right? So if we press enter, you may note that only from 2 to 4 has been displayed. So if I want to mention from 2 to 3, so now it will give us only the second and the third column corresponding to the first, corresponding to the row 2, 3, and 4. So now we have, similarly you can think of so many other values and so many other things. Similarly, we can also do like this, that if we want to select from row 1 to row 5, but we want to select only the odd rows, right? So we can mention that. And in this case, it will select from row number 1 up to row number 5 with a space of 2, right? So it will select row number 1. If we look at T itself, so it has selected row number 1, and then it did not select the second one, and then it select the third one, and then it does not select this one, and then it select this. So what essentially it means, 1 to 2 to 5, is to generate numbers from 1 to 5 with a step size of 2, right? So in this case it has select row number 1, row number 3, and row number 5. Similarly, if we are working with a very large table and we do not know the end point of that table, so and we want to manipulate it like that, so in this case we can always mention the special reserved word end. So whatever the size of the table is in this case, it will be represented by the end value, and then it will do selection as like this, that the row number 1 will be selected, then 3, then 5, and so on. Right? So similarly, we can change the order as well, and we can say that select starting from the end, do not select 1 and come all the way up to row number 1. So it will now reorder the selection. Right? So it has selected the last one first, and then it does not select this one, and then it select this one, and this is skipped, and then this one was being also selected. So this was an easy way how you can actually select different rows and different columns. Similarly, if you want to rearrange the values over here, that is the column names, you want to rearrange these columns. So we can also do that with the colon operator, and we can say T corresponding to all rows. I want to mention that, okay, my column number 1 will be column number 3, my column number 2 is going to be column number 1, and column number 3 is going to be column number 2. So I can mention that order over here. And when I press enter, you may notice that the column number 3 is now appearing in the first position. The column number 1 has been shifted to column number 2, and column number 3 is our column number 2 here, that is height foots. So this way we can rearrange our variables in the table environment. In the next few segments, we will be also looking at some of the more complex ways to make selection of rows based on some condition, right? So that will be based on some logical operation.